Welcome to On Chemistry. In this video, we are going to see how to find shape of molecules. The molecule can be of any shapes. We are going to see easy formula, shortcuts and tricks and quick way to find the structures. Stay tuned. Here I given the library of shapes. Better you memorize it or understand it. It will help you to solve the problems. Known shapes are trigonal planar, tetrahedral, trigonal bipyramidal, octahedral, square planar, bend shape or V shape, trigonal pyramidal, square pyramidal, Caesar and T shapes. These are all the most common shapes. Better you know it. Then I given references of hybridization of known molecule. Suppose you want to solve by yourself. This will help you to solve and understand. Make use of it. Then the next library for the references where the lone pair comes. Here size of electron in lone pair is always less. Size of atoms are higher. So shape mean without lone pair. So in all the structure, position of lone pair is critical. Number of lone pair is critical. This information help you to avoid the confusion. Now we are getting into the real formula. To find the hybridization, you should know the steric number. Basically, it is come from VSEPR theory that we call as H. H is 3 mean sp2, 4 mean sp3, 5 mean sp3d, 6 mean sp3d2. The shapes accordingly varies. 3 mean trigonal planar, 4 mean tetrahedral, 5 mean trigonal bipyramidal, 6 mean octahedral. Here the formula is H equals V plus B minus C whole divided by 2. The number of lone pair is H minus B. Here V is for valency of central metal atom, B is bonded atom, C is charge. Then the important basic you should know is repulsion. Lone pair repulsion is higher than lone pair bond pair, which is higher than bond pair and bond pair. So always avoid lone pair interaction. The another fact is geometry mean with lone pair, shape mean without lone pair. Why? Because size of electron is lesser than the size of the atom, so it is not visible. So shape mean without the lone pair. Here exception come for oxygen. While counting, you should not count for bonded atom, but you should count for bond pair. Then the basics. What is central metal atom? What is lone pair? What is bond pair? Central metal atom is the atom which is normally bigger, only one in count, mostly high atomic number, which will hold all other atoms at position center. The connected atoms are called bonded atom. The electron which bond both the atom is called bond pair. So central metal atom, bond pair. Lone pair means the pair of electron don't involve in the bonding, but it will sit on the central metal atom. So lone pair, bond pair is different. The repulsion of lone pair is higher. So while analyzing the shape, the important fact is position of lone pair. Then the very important fact, difference between geometry and shape. Here I given the structure of ammonia. Ammonia with 3 bond pair and 1 lone pair. If you want to say geometry, it is tetrahedral. If you want to say shape, it is trigonal pyramidal. Why? Because electron is so smaller when compared to atom, so it is not visible. So ammonia geometry is tetrahedral. Shape is trigonal pyramidal. Then the important fact where the lone pair will come. In trigonal planar structure, lone pair can come in any way. In tetrahedral, all the bonds are equal. So lone pair come in maximum angle. Trigonal bipyramidal, lone pair always occupy equatorial position. 1, 2, 3, all will take equatorial position. Octahedral is crucial. 1 lone pair mean equatorial. 2 lone pair mean repulsion maximum in equatorial position. Axial will give better angle. So axial transposition come. 3 mean equatorial. So simple fact you should know here is lone pair always come in equatorial. step-by-step procedure to find the structure. First you find the central metal atom, then you count the valency of central metal atom, that is V, then count the bonded atom, that is B, identify the charge, if it is there, it is C, then calculate the steric number by our formula, write the hybridization and save, then calculate the lone pair, find the real shape. Here the important fact is hydrogen is the whole number, never come as fraction. Here one important thing is valency. You should memorize at least first 20 elements. The valency will be mostly atomic number for first row. Here memorization will be easy. All the elements are arranged by its electronic configuration. First atom of the group and all other will have same electronic configuration. So better memorize first 20 elements. Then the important thing, exception in the analysis, case of oxygen. Our formula will be perfect if oxygen is not present. If oxygen is present means you should not count bonded atom for steric number. Here XeO3 given as an example. While calculating valency of xenon is 8, it is a octet inert gas and bonded atoms should count as 0 not 3. So if you do it, 8 plus 0 minus 0 divided by 2 mean 8 by 2 gives 4. Don't count the oxygen here. In the lone pair case, you should count the oxygen. In that case, 4 minus 3 gives 1. So you should count for oxygen when in lone pair. Don't count in steric number. Best way to learn the concept is problem because it will give you maximum understanding and clarity. In the first example, here I given BCl3, boron trichloride. Here central metal atom is boron, valency is 3 and 3 chlorine atoms are there. So bonded atoms are 3. So steric number will be H 3 plus 3, no charge is there, 0 divided by 2. 6 by 2 gives 3. Lone pair will be H minus B, which is 3 minus 3 gives 0. H3 mean sp2 hybridization. sp2 hybridization mean trigonal planar. No lone pair is there. 3 bonded atom. No lone pair is there mean trigonal planar. You can clearly see all 3 atoms in the corner of triangle. It is a planar structure. In 3D animation, you could see very clearly. So, the shape of BCl3 is trigonal planar. Then the next example, XeF4. Xe is inert gas, so octet. Valency is 8. It is a central metal atom, so V is 8. Bonded atoms are fluorine, that is 4. So steric number will be H equals 8 plus 4 minus 0 divided by 2 mean 12 by 2 gives 6. Lone pair will be H minus B, which is 6 minus 4 gives 2. H6 mean sp3d2 hybridization, which is octahedral geometry. Here 4 bonded atoms are there, 2 lone pair you should position in the octahedral, 2 lone pair come in the axial position because that is in maximum angle. So geometry is octahedral, lone pair is not visible, so only fluorine atoms are visible. That is square planar structure. So shape of XeF4 is square planar. Then the third example, I3 minus. It is very interesting example because central metal atom and bonded atom both are same iodine. Since iodine is bigger, it is possible. Iodine valency is 7, it is halogen and it bonded with 2 iodine atom. So bonded atoms are 2, charge is minus 1. So steric number will be 7 plus 2 minus of minus 1 by 2. So it will be 10 by 2 gives 5. So lone pair will be H minus B, which is 5 minus 2 gives 3. H5 mean sp3d1 hybridization, trigonal bipyramidal. 3 lone pairs are there, 2 bonded atoms are there, 3 lone pairs are there, 2 two bonded atoms are there in trigonal bipyramidal. Lone pair come in equatorial position. Axial position iodine will come. So if you look at it, geometry will be trigonal bipyramidal. Lone pair is not visible. So shape is linear. So shape of I3 minus is linear. Then the fourth example, XeCl3 plus. Here central metal atom is xenon, which is inert gas. So valency is 8. Bonded atoms are chlorine. So 3 bonded atom. So B is 3. Steric number will be H equals 8 plus 3 minus 1 by 2, which is 10 by 2, 5. Lone pair will be H minus B, which is 5 minus 3 gives 2. So H5 means sp3d1 hybridization, which is trigonal bipyramidal. You have two lone pair. Lone pair occupy equatorial position. So lone pair in equatorial, 3 chlorine like T-like position. Geometry will be trigonal bipyramidal. Shape will be T-shape. So the shape of XeCl3 plus is T-shape. Then the next example, PCl3F2. Here central metal atom is phosphorus. It holds chlorine and fluorine. Phosphorus valency is 5, which is nitrogen group. Total bonded atoms are 5. Total bonded atoms are 5, which is chlorine and fluorine. Steric number will be H equals 5 plus 5 minus 0 by 2, 10 by 2, 5. Lone pair will be H minus B, which is 5 minus 5 gives 0. H5 means sp3 dehybridization, trigonal bipyramidal. Here confusing fact is where fluorine and chlorine will come. Here most electronegative fluorine will come in axial position. It is the rule, memorize it. So fluorine come in axial, chlorine in equatorial. So the shape of PCl3F2 is trigonal bipyramidal.